everyone, welcome back to your channel Chemistry Simplified for Biomolecules Class 12 Part 2. Okay, now in the previous class we have discussed about the classification of carbohydrates. We discussed about the Fischer structure of glucose. So in today's class we are going to discuss about the configuration of glucose. We will talk about the cyclic structure of glucose. Then we will move on to understand fructose, disaccharides, polysaccharides, and also the importance of carbohydrates. Okay, so let's begin today's video. Okay, so first of all, we are going to understand what is the configuration of glucose. For this, I am writing here the Fischer structure also. So generally, you have seen that we often write it as the D and L configuration. Okay, so what is the difference between D and small d, or D, small d, or positive or minus sign? Okay, are they same or they are different? They are definitely different. Okay, now what is the difference? Here what we are going to talk about is basically the relative configuration of glucose with respect to the glyceraldehyde. Okay, now what is the difference? Let me draw glyceraldehyde. What is this? Another one is this. Okay, now we know that glyceraldehyde, this is glyceraldehyde, okay? This is glyceraldehyde. This is glyceraldehyde. Okay, now what is the difference here? This capital D denotes the notation, okay, of the OH, which is just adjacent to the CH2OH. Okay, here what is asymmetric carbon? First of all, let us understand. This is my asymmetric carbon. That's chiral carbon. Okay, you know what is a chiral carbon? Which is connected with 4 different carbons. So in glyceraldehyde, हमारे पास एक carbon है which is asymmetric. ठीक है? So when we write the configuration of glucose with respect to this, we have to see that the lowest asymmetric carbon, the hydroxyl group which is attached to the lowest asymmetric carbon, lies either on the right hand side or on the left hand side. अगर ये हमारा एक hydroxyl group right hand side पे है हमारे इस lowest asymmetric carbon, okay, then in that case it is having a configuration of D. Okay. And if the OH is on the left hand side, then it will have a configuration of N. Okay. Now what is this positive sign and negative sign means? The positive sign shows that it is the optical activity. That means how does it rotate the plane polarized light? If it rotates the plane polarized light towards the right hand side or clockwise direction, then it is having a plus, that is dextrorotatory. If it rotates the plane polarized light in the anti-clockwise direction, then it is levorotatory. Okay, so if we compare with respect to glyceraldehyde, glucose, if it is having how many asymmetric carbons? 1, 2, 3, and 4. Okay. So here the lowest one is this OH. If it is present on the right hand side of the CH2OH, then it is having a D configuration. And if it rotates it into clockwise direction, then it is having a positive sign. clockwise, if it rotates anti-clockwise, then it will have a D minus series because it belongs to a D series. Okay, so this is the configuration of glucose with respect to glyceraldehyde. Okay. Now the next thing is that why is the need to find the cyclic structure of glucose? क्या जरूरत पड़ी? ठीक है, तो जरूरत पड़ी. Basically ये हम देखते हैं Fisher structure of glucose. In this structure, we have read so many evidences, right? How it reacts with mild oxidizing agent, how it reacts with strong oxidizing agent, what are the products which are formed. But despite the first point for this is, despite having the aldehydic group, it does not give Skiff's test. Okay. Also, it does not give any addition product. It does not give addition product with hydrogen sulfide with NaHSO3. Okay, this is the first reason. Secondly, the pentacetate of glucose, does not react with hydroxylamine, thus confirming the absence of the aldehydic group CHO. Okay. Also, it was found that the glucose exists in two crystalline forms. That is alpha glucose and beta glucose. Okay, with melting point 419 Kelvin. So melting point, and this is having a melting point of 423 Kelvin. The alpha glucose, which is obtained by the crystallization of concentrated solution of glucose, okay, at 303 Kelvin, whereas beta glucose, it is obtained by the crystallization of a saturated aqueous solution of glucose, okay, at 371 Kelvin. So, because the Fisher structure was not able to justify these facts, that is why it was proposed that the hydroxyl group of at the carbon 5, this is 1, 2, 3, 4 and 5. It was proposed that the hydroxyl group adds to the aldehydic group to form a hemicyclic acetate. Cyclic hemiacetal basically, right? Okay. So why only carbon 5? So let us see this. If you want to take a screenshot, you can take. We'll discuss about the cyclic structure of glucose. You can see here. Okay, so this is the structure of glucose. Okay, the open structure of glucose. It contains. Now in this, what was observed? ये देखा गया कि ये जो कार्बन 5 पे जो हाइड्रोक्सिल ग्रुप है, वो क्या कर रहा है? वो न्यूक्लियोफिलिक अटैक कर रहा है कार्बन 1 के कार्बन पे, aldehydic group पे basically. Okay, because it is having a lone pair electron, it is going to attack here. Okay, and Thus, it is going to form a 6-membered cyclic ring, which is a cyclic hemiacetal. Okay. Thus, it will form two structure, that is alpha glucose and beta glucose. कैसे बनेगा? Let us draw. I'm sorry. No, first let me show you like this, and then I will draw the Howard projection also. Okay. So it is. And both exist in equilibrium. So this is how the cyclic hemiacetal form is made. Now we have to represent this in a Howard projection. How? Now since this structure, the only difference, remember this point, the only difference between these two forms is because of the hydroxyl group which is present at first carbon. Okay, so the only difference lies in the configuration of the OH present at the first carbon, and thus this form is known as anomeric form, or we can call it as these two are the anomeric isomers. A question which is often asked in board exams. What are anomers? Okay, so these two are the anomeric form of glucose. Okay, now since the structure resembles to the structure of pyran, that is why it is also known as pyranose, okay, which is a 6-member ring having an oxygen atom and 5 carbon atom. Let me show you how. Please keep taking notes. So the structure of alpha and beta glucose is 5. Okay, in alpha glucose, and I'll just show you what is the difference here. The only difference is because of the OH group at first carbon. Okay, this is the first carbon. This is beta glucose. How to remember अल्फा एंड बीटा? सो अ सिंपल ट्रिक फ्रॉम माय साइड, ये क्या है, यहाँ पे आपका CH2OH, ओके, अप डाउन एंड डाउन. दिस इज फॉर अल्फा. दिस इज माय way you find it easy. ठीक है, ये अल्फा ग्लूकोज है, ये बीटा ग्लूकोज का स्ट्रक्चर. So this is the structure of glucose, the Haworth projection. This is called Haworth. So we have discussed both what is glucose, what are the evidences for the Fischer, the open chain structure of glucose. Then we have discussed what are the why we needed a cyclic structure, how the cyclic structure is formed because of the nucleophilic attack of the OH present at the fifth carbon. Hydroxyl of the fifth carbon gets attached to the aldehyde group which is present at the first carbon. ठीक है, to give form to a 6-membered hemiacetal ring. Okay. Now this is alpha glucose and this is beta glucose. Now just likewise this, we have this next thing is fructose. Again, you know that fructose is also the product of hydrolysis, just like the glucose. It is also the hydrolysis product of a disaccharide, that is sugar, with the molecular formula C6H12O6. Fructose. Fructose also a product of hydrolysis of a disaccharide, sucrose, that is C6H12O6. Okay. It is also known as the ketohexose. Keto is the ketonic group and hex same is for 6th carbon. Okay. Now, what is the open chain structure? Here, CH2OH, second position, UH, OH, 5 and 6. Okay, so this is the open chain structure for fructose. Just like the glucose, fructose also exists in two forms, okay, alpha and beta. Since it is, though it is belongs to D series, then also it is a laboratory compound. That means it rotates the plane polarized light in the anti-clockwise direction. Now, the cyclic form is related to, here again, the fifth carbon, fifth hydroxyl, the hydroxyl which is present in the fifth carbon, it adds up to the second carbon of the ketonic group to form a 5-membered ring which is related to, or with the structure is similar to the structure of furan, and that is why it is known as furanose. Okay, fructofuranose. Again, it exists as in the form of alpha fructonose and beta fructofuranose. Okay, so if you want, let me draw the structure for that also. Remember, when we are writing alpha, the OH is down. When we write beta, the OH is up. This is the structure of your beta alpha fructofuranose. Or we can simply write alpha fructose and beta. It is a laboratory compound. hope you are getting this. Okay, fructose and glucose, they are very similar. The only difference lies in the functional group. Glucose has an aldehyde group and fructose has a ketone. Okay, so the existence is very similar. Now I hope you have understood this much. Now we will move on to the next important thing, that is a disaccharide. We have learned what is a disaccharide. What is a disaccharide? What is a disaccharide? In the previous class we have learned that the oligosaccharides they yield 2 to 10 units of on hydrolysis, right? They can be disaccharides, they can be trisaccharides, they can be tetra, they can be so many more, right? So when two monosaccharide units combine together by a glycosidic linkage, then they are known as a disaccharide. What is a disaccharide? डाइसैकराइड क्या होते हैं डाइसैकराइड्स? जब हम दो मोनोसैकराइड्स को ऐड करते हैं, आई एम सेइंग लाइक दिस, दे बोथ रिएक्ट टुगेदर बेसिकली and they form a bond, they are combined together by a glycosidic linkage, then they are said to be a disaccharide. अब ये disaccharide और ये glycosidic linkage होता क्या है भला? Let us see. In this we will see, we'll understand different disaccharides. First of all is sucrose. Sucrose. Let's have a molecular formula C12H22O11. Sucrose. Sucrose is a disaccharide which on hydrolysis gives equimolar mixture of glucose and fructose. Okay, it gives C6H12O6, glucose and fructose. How this glucose and fructose combined together will give me a disaccharide, that is sugar. So here what will happen is, here the alpha D glucose and beta D fructose will combine the carbon 1 of the alpha D glucose and carbon 4 of the carbon 2 of the beta fructose will join together through a glycosidic linkage and will form a disaccharide, that is sucrose. Let us see how. Well, we have just learned the structure. This is your alpha glucose. This is your alpha. I am showing you by making. And we have just learned the beta glucose. This is carbon 1. Just put it as carbon 1. This is beta fructose, which will combine second carbon. How this glycosidic linkage? Here, carbon 1 of alpha D glucose, carbon 2 of beta D fructose. कैसे बनेगा glycosidic linkage? Glycosidic linkage is formed by the removal of a water molecule, okay, between these two. From here, we remove a water molecule to form a glycosidic linkage. So the actual structure of glucose or of this sucrose, we will get it like this. Okay, keep practicing this structure so you will remember it, because obviously we will be getting it to draw. Okay, this is your glycosidic linkage. One thing, what we notice here is we can see that the aldehydic group of the glucose is not free here. Okay, so this also proves that why sucrose is a non-reducing sugar, because here the aldehydic group is not free and therefore sucrose is a non-reducing sugar. Okay. Now, point to remember, important note is that the sucrose is a dextrorotatory compound. Okay, sugar is dextrorotatory, but on hydrolysis, sugar is dextrorotatory, but on hydrolysis, it gives a dextrorotatory glucose and levorotatory fructose. On hydrolysis, it gives dextrorotatory glucose and levorotatory fructose. And what? It gives levorotatory fructose. But since the rotation of this levorotatory fructose is more, that is almost minus 92.4 degree more as compared to the dextrorotatory glucose, that is around 52.5 degree. And that is why the mixture is levorotatory. There is also a question is asked, what is invert sugar? So this is what is an invert sugar. What I said, I will repeat it. So here, this hydrolysis of, here you can see from NCERT, thus hydrolysis of sucrose brings about a change in the sign. So, change in the sign of rotation from dextro to levo, and the product is named as invert sugar. Question comes in CBSE that why it is invert, what do you understand by invert sugar? So, what we have seen here is, हमने क्या देखा? Sucrose क्या है? Disaccharide. Disaccharide है because it gives alpha glucose and beta fructose. ठीक है? This disaccharide is formed when two monosaccharides. What are these two monosaccharides? Alpha glucose and beta fructose. When they combine together by a glycosidic linkage, here we can see that the aldehyde group is not free, and because it is not free, it is a non-reducing sugar. ठीक है? पहला point. दूसरा, this sugar, the sucrose is dextrorotatory, but on hydrolysis, जब इसकी hydrolysis होती है, वो क्या करता है? It gives a dextrorotatory product of glucose and levorotatory product of fructose. But because the rotation of fructose is more as compared to the dextrorotatory glucose, that is why the mixture is levorotatory. Thus, on hydrolysis, the dextro is converted to levo, and that is why it is known as invert sugar. Okay, I hope this is clear. You can take a screenshot we'll move on to the next disaccharide, that is maltose. Is maltose. Another side disaccharide, which is maltose. Okay, so maltose is composed of, first again, two monosaccharides, that is alpha glucose and alpha glucose. That means two alpha glucose unit combined together by a glycosidic linkage and form a maltose. Okay, let us see how. Here, the carbon 1 and carbon 4 gets linked to each other by a glycosidic linkage. What is the structure of alpha glucose? You have to practice it. The more you practice, the more you will understand. One, two, three. This is 1, 2, 3, 4, 5. Since it is alpha, so OH will be at the bottom. Up, down, and down. Up, down, and down. Okay, this is a trick which I use personally, but it is up to you. Okay, so these are the two alpha glucose. So here the carbon 1 and carbon 4, they combine together by removing a water molecule, thus forming a glycosidic linkage. Okay, now what is important here to understand is, just to show you, now I'm not writing everything, here you understand only that the linkage. Practice in order to master it. Okay. Now here, this is the glycosidic linkage. Now, can you tell me whether it is a reducing sugar or a non-reducing sugar? Is there any difference in the previous one, sucrose, and this figure, maltose? Yes, of course. Here what we can see is the aldehydic group at the carbon 1 position is free, and because the aldehydic group is free, that is why it is a reducing sugar. It is a reducing sugar. Okay. Next disaccharide we have is lactose, which is a milk sugar. Why I am writing milk sugar? Because it is present in milk. Okay. Now, how it is formed? So here, the carbon 1 of alpha D glucose and alpha D glucose. Again, here also the carbon 1 of alpha galactose and carbon 4 of glucose, they blend together to form a glycosidic linkage to form a lactose. Okay, so let me show you. So in this case, here, I think I have written something wrong. Yes, actually it is, sorry for the, it will be beta D galactose and beta glucose. Sorry about this. Beta galactose and beta glucose. Yes. Right. Okay. So here what we can see again, how we will write the linkage. Everything is right. So here you can see a removal of water molecule from here to form a glycosidic linkage. What we will get? So here what we can see again, in this case also we can see that the glucose is the aldehyde group is also free, that is why it is also a reducing sugar. Okay, so you can note down and we will move on to the next topic. Take a screenshot. So what we have learned here in this disaccharides, we have sucrose, which is a non-reducing sugar. We have maltose, which is a reducing sugar, and we have lactose, which is also a reducing. Now you should remember the products of these. Okay, so sucrose का product क्या है? One is alpha glucose and beta fructose. Maltose के लिए alpha glucose and alpha glucose, and for lactose we have beta galactose and beta glucose, beta D galactose and beta glucose. Okay. Next we will move on to polysaccharides. We have learned what are polysaccharides. Polysaccharides which give large number of small units on hydrolysis. That is polysaccharides. This chapter is theoretical, and if you do this it properly, you can score good marks in this, because every time there are some questions which are coming, either it is a 1 mark or 2 mark or 3 and like this. Okay, so some questions like what are animals, what are the evidences of why, what is the need of cyclic structure, in reasoning questions that can be asked. Okay, so the next we have is polysaccharide. So you can give the heading polysaccharides. What are polysaccharides? Basically, these polysaccharides, they contain large number of molecules, okay, on amino acids, as we have already discussed. In this, we are going to discuss 2-3 important points. First is starch. What is starch? According to your NCERT, starch is the main storage polysaccharide of plant. I'll just read out from NCERT one and then I'll explain it. So according to NCERT, starch is the main storage polysaccharide of plant. It is the most important dietary sources for human beings, and high content of starch is found in cereals, roots, tubers and some vegetables. Okay, so it is a polymer of alpha glucose and it consists of 2 components. Okay, that was your NCERT. NCERT says that starch is a polymer of alpha glucose and it contains 2 components. What are these 2 components? These 2 components are amylose and amylopectin. What is starch? Starch is a polymer of alpha glucose and it has 2 components, that is amylose and amylopectin. So let us discuss what is amylose and we will discuss amylopectin. First is amylose. You can note down what is amylose. First of all, amylose is water soluble component. It is a water soluble component. Contains around 15 to 20% of starch. Okay, so it is a water soluble component which contains around 15 to 20% starch. It has a long unbranched chain. It has a long unbranched chain of around with 20 to 1000 alpha glucose units. It has a long unbranched chain of about 200 to 1000 alpha D glucose units. Okay, which are again held by the glycosidic linkage, which are held by glycosidic linkage between C1 to C4. How? So let us find out. We have already done it. You can, meanwhile I am drawing it on the board, you also try by yourself. It's very easy if you practice. You also draw, I will also draw. glycosidic linkage between carbon 1 and carbon 4. Carbon 1 and carbon 4. Okay. So from here, water molecule is removed. From here, water molecule is removed. So what we will get? And now I'll only draw this skeletal structure. Okay. Glycosidic linkage. Okay, so I hope this is known as the alpha link. This is the alpha link. Okay, so what is amylose? What is starch? Starch is a polymer of alpha glucose. It has two components, amylose and amylopectin. Amylose, which is water soluble component, contains 15 to 20% of starch. It has long unbranched chain of 200,000 units, alpha glucose units, which are held by glycosidic linkage between carbon 1 and carbon 4. So this is how we denote it. Okay. The next is amylopectin. What is amylopectin? Again, amylopectin here is insoluble in water. Okay. This was soluble. This is insoluble in water, and it contains around 80 to 85% of starch. 80 to 85% starch. Okay, and it forms a long. It has a carbon chain with linkage of carbon 1 and carbon 4, but the branching takes place between first carbon and the sixth carbon. Okay, so we can also try to draw that. Meanwhile, you can also try. I'm sure this carbon 1 and carbon 4 you have already understood. I'm simply drawing the first and sixth position carbon here only, so you can understand. Through this diagram only you can understand. This is the first carbon and this is the sixth carbon. Okay, so here there will be a bond between the first and the sixth carbon. Okay, so this CH2OH, as you can see here, I will just remove it so that you can understand. CH2. Okay, so there will be this bond like this, the branching. And likewise, it will continue the sixth carbon and the first carbon. So there is a C branching at carbon 1 and carbon 6. That's the only difference between amylose and amylopectin. Okay. Then we have next is cellulose. What is cellulose now? We know that cellulose again exclusively occurs, or it is present in the plants, and is one of the most important, or we can say it's a component of the cell, of the basically cell and the plant kingdom, right? So what is the difference? What is important here? So here there is the glycosidic, there is a beta link between, in the beta linkage between the cellulose. Okay. The next we have glycogen. What is glycogen? We are not dealing. Okay. If you want, I can give you the short notes. Again, what is cellulose? Cellulose is a straight chain polysaccharide compound of beta D glucose unit. ठीक है? अभी तक हम क्या पढ़ रहे थे? Alpha, alpha, alpha. So this is a straight chain polymer of cellulose is a straight chain. It is a straight chain glucose unit. Beta D glucose unit. And again, if you want to draw beta glucose unit, it will be like this. Okay, this is the carbon 1 of glucose unit, and it will combine with carbon 4. So I will draw it like this. This is the 4th carbon. OH. And here, this is 1st carbon. So basically there will be a linkage. यहाँ से आप water molecule हटाकर देख लो. I'm not drawing all the structure. You can practice by yourself here. But मैं आपको बस इतना बता रही हूँ कि यहाँ पे आपका carbon 1 and carbon 4 there will be a linkage. Carbon 1 and carbon 4 के बीच में ये बीटा लिंक बनेगा. ठीक है? Then we have glycogen. Again, glycogen is the carbohydrate that is stored in animals. Okay. So the 3 polysaccharides we have discussed. We have starch, which is a polymer of alpha glucose. Okay. It contains 2 components, amylose and amylopectin. Amylose is water soluble, contains 50 to 20% starch. It has long and branch chain of 200 to 1000 alpha D glucose units. Whereas amylopectin is insoluble in water, it contains 80 to 85% starch. It does the branching at carbon 1 and carbon 6. Cellulose, it is again a straight chain polysaccharide of beta D glucose and having beta link. The third one is glycogen, which is a carbohydrate which is present in the that is stored in the animal body as glycogen. Also, it is known as the animal starch. Okay. Then what is the importance of carbohydrate? You know that carbohydrates is very, very essential, or not just for human beings but also for the animals. Okay, it is essential for both animals as well as plants. It is also used as a storage material. Okay, also it is used for various materials, provides raw materials for various things like in textile and paper industry. Okay. So I think we have completed carbohydrates. So just recap once what we have learned in this series. In this video we have learned about the configuration of glucose, which is a D configuration. Okay. Then we discussed about the cyclic structure of glucose. We discussed about the disaccharides. Then in disaccharides, what we have learned? In disaccharides we have discussed about the sucrose, maltose and lactose. Then we have discussed product of sucrose is alpha glucose and beta fructose. The maltose, alpha glucose and 2 units of alpha glucose joined together by glycosidic linkage. Then lactose we have beta D-galactose and beta glucose. Okay. Then we discuss about polysaccharides like starch, cellulose, glycogen, etc. Okay. I hope you have understood what I have taught today. If there is any doubt, please do comment and send your queries to me. I'll try to rectify myself. If anything you want to know, if you want to have any notes and all, you can simply message me. Okay, I'll provide you with the notes also. All this for today. More we have to discuss like vitamins, nucleic acids, that we'll be discussing in the next video. So if you like my video, do not forget to like, comment and subscribe. Thank you so much. Have a good day.